We want to solve a triangle where we have certain pieces of information being given to us. As always, when I'm solving a triangle, I am going to create myself a little sketch to visualize, to see what it is that I have been given. Alright, so I have three pieces. I have the angle capital A down here on the corner, let's say. This angle is being given to us, and this is 77.1 degrees. Then I have the side length opposite of this angle, little a, which is supposed to be 12.8 feet. Now I have a side length b, little b, is equal to 9.5 feet. I could have labeled the side length on the bottom b, that wouldn't really have changed anything, but this is how I did it right here, because our typical triangle is being labeled as this: A on the bottom left, angle B on the bottom right, and angle C on the top. Little c length is down here on the bottom. So, three things we need to find. Now, let's have a look. If I'm organizing my work, what I have been given right here is a side length, another side length, and an angle that is attached to the side in the middle. This is our side-side angle axiom, and if I have these kind of informations, then there are always three possible outcomes. The first outcome is that I have exactly one triangle that I can create with these informations. The second possible outcome is that there are two triangles that I can create with these information. This will be the one that will demand the most kind of work. The last possible outcome is that there is no triangle possible. So let's go ahead and see what we're going to do. We're going to use the law of sines to find the measurement of angle B. So the law of sines is going to look like this, that we are going to have the sine of B divided by the length opposite of this angle is equal to the sine of A divided by the length opposite of this angle. 3 out of these 4 unknowns I know, and that means that I can solve this equation for sine of B. And now I'm just going to substitute the values in that I've been given. All right. Measurement of side B was 9.5 feet times the sine of 77.1 degrees. Remember to set your calculator onto degrees when you do this calculation. So you see what happens to the units. They're going to cancel out, and that means I'm going to get exactly what I was hoping for. I'm going to get the sine. I'm going to get a number below 1. If the value right here is above 1, and now my calculator just... there it is. If the value would have been above 1, well, that would have told me that I cannot create a triangle with the given pieces of information because there is no sine output value that would be bigger than 1. All right, but the number is between 0 and 1, and that means I can use now the sine inverse operation on my calculator to recover what angle B is supposed to be. The sine of B all I have to do now is to use the sine inverse function. This is the very definition of the inverse of a function, that the sine inverse of sine of b is equal to b. And for us, in this case, the first value that it is going to spit out, you may use the answer button to use what you have inside your calculator. That will say 46.34. We are supposed to round this to the nearest tenth. So let's gonna say the angle is 46.3 degrees. Now we have a bit of a problem here because, strictly speaking, the supplement of a 46.3 degree angle's sine would also be 0.72345 and so on. So we have to look for a possible second candidate in just a moment. The second candidate right here, B2, that would be, hold on, what is 180 minus 46.3 degrees? Let's have a look. 180 minus 46.3. That would be 133.7 degrees. Now, the reason why we are checking this, because sine of 133.7 is also 0.72345. So in other words, if this is an angle, 133.7 degree, that would be possible, then we have to consider this angle as well. When I'm looking, though, at the first angle that I have been given in my triangle, which was 77.1 degrees, one of the angles I know, and 77.1 degrees plus 133.7, now we have a problem because this is bigger than 180 degrees. And that means that the second angle right here was not an option. This is not an option. And that means right now I can answer the first part of my question. The first part of my question is now, I know exactly how many triangles I could find. One triangle. Because, again, the second angle B would have been too big to be considered. Now, to find the remaining angle C, I also have therefore now only one C to find, and that would be, let's have a look. 180 degrees is the sum of all three triangles in Euclidean geometry, or in our planar trigonometry that we are using here. And that means all I have to do, I subtract the angle A, I subtract the angle B that I have found, and I am going to get, let's have a quick look, 180 minus 77.1 minus 46.3, and we get that this is 56.6 degrees.